Welcome to episode 2 of the PowerShell series. In the last episode, we talked about the basics of PowerShell, including installing PowerShell, command basics, navigation and file management, and getting help. If you've missed that episode, check it out somewhere here, since today's episode assumes you've watched the first one. In today's episode, we're going to be covering objects, including their properties and methods, the PowerShell pipeline, formatting, aliases, and comparison operators. That is a lot to go through. And this episode is slightly longer than I would have wanted it to be, so feel free to take a few breaks in between. Anyway, we'll have a lot to cover, so let's get started. Okay, so here I am on my Windows desktop and I have PowerShell 7 ready to go. However, what I'm going to show you today works in pretty much all versions of PowerShell. So one really important thing to understand about PowerShell is that it works with objects, properties, and methods. If you've ever done object-oriented programming, this will be very familiar. If you haven't, don't worry, I will explain. So for example, I'm going to type get service name, and we'll go with our favorite service here, Windows 32 time. Now, if we go here, you'll see that I get a status, a name, and a display name. Okay, running, blah, blah, blah. Now, these things here, status, name, and the display name, these are all properties. Properties give us information about objects. Now, if I want to get more information, I can pipe this entire command here to get member. And what this does is it shows me all of the properties and all of the members of this particular service. So the properties are used to get information about an object. So for example, for this Win32 time service, you'll see that there is a display name property, which shows me the name of the service, service type, which is obviously the type of service, username, who's currently running the service, and so on and so forth. So properties are information about something. Methods, on the other hand, are things that this object can do. For example, I can start the time service, I can stop it, refresh it, pause it, dispose of it, close it, continue, and so on. So basically, properties are information about an object and methods are what that object can do. And here we can see that there are several properties and methods, and this is important because everything in PowerShell is basically an object. Now you will notice that I used the getMember command to get this information. And the reason for this is very simple, guys, because methods and properties together are called members. So when you have an object, the methods and properties are called methods. So if you had to compare this to a dog, for example, properties of the dog would be breed, name, age, gender, and so on. Methods would be bark, poo, sleep, run, and so on. For this Win32 time service, there are different properties and methods which are called members. Now, at the top of the output, this very important part here tells you what type of object this is. So the Win32 time object is of type service controller. Okay? So I know that the Win32 time object is of the service controller type. For those of you into object-oriented programming, service controller is the class, whereas Win32 time is an object created from that class. The basic idea here is that any properties and methods which are defined in this class, any type of object which is of this type will also have. So now that we know the object type, we can check what commands accept this object as a parameter. So to do that, we can say get command dash parameter type service controller, which remember is our object type here. And so what is being told here is that all of these commandlets, get service, remove service, and so on, can accept a service controller object as a parameter, including win32 time. So for example, I can use the start service commandlet to start the win32 time service, the stop service commandlet to stop the Windows 32 time service, and so on and so forth. Okay? Now, this list here that get member displays doesn't necessarily show all of the methods and properties. The output is limited by default. So to get everything, what we can do is we can say get service name win32 time, and then we can pipe it into select object property, and then an asterisk. So what is this command doing here? It's saying get the win32 time service and then pass it through select object, which is used to get something from an object, some member. And what we're telling it here is to get the property, and which property? Asterisk, which is a wildcard, meaning all. So this basically says, show me all the properties of the win32 time object. And when I press enter, you'll see that all of the properties are displayed, and it even shows me their current value. Okay, so display name is Windows time, can shutdown is true, can stop is true, and so on and so forth. So these are these properties. Now, besides selecting all the properties, which is what I did with this asterisk, I can actually specify which properties I want to see. For example, I only want to see the status, the name, the display name, and the service type. And as you can see, these properties are displayed with their the name of the property, status, name, display name, and so on, and then the value. Now notice how in this case, PowerShell is showing the output as a table, but in the previous case, it's showing the output as a list. Now the reason for this is that by default, any command which produces more than 4 properties of output, okay, will be shown as a list. So in this case, since we're displaying all the properties, we get a list. However, since in this case we're only showing 4 properties, we get them as a table. If we had to add another property to this, for example, we add a start type, notice how I now get a list. Okay, so the default limit is that up to 4 things, they will be displayed as a table. Now later on in this episode, I'm also going to show you how you can change that. Okay, but for now, it's good to know what the defaults are. So I'm going to clear the screen for now, and I'm going to go back to one of my previous commands. Get service, name, win32 time, and then I'm going to pipe it to get member. Now we've already seen this before. This basically shows us the methods and properties. However, this itself can be filtered. Okay, so I can go here, back to the previous command, and then I'm going to say dash member type, for example, method. And as you can see, now it only shows me the method. So basically, when you want to discover the properties or methods of something, it's very easy to do it using getMember and then specify what you want to see. In this case, for example, I am showing the properties. Now, going back to the methods, you can see that one of them is stop. Now, as you would imagine, calling the stop method on the win32 time service would actually stop it. So how would you do that? Well, I can say, open brackets, get service, name, win32 time, close brackets, dot stop. So what this does, guys, is it first obviously executes what's inside the bracket, just like you do in math. So basically this will return an object, and our object will be a service controller object that is representing, in our case, win32 time. With that object, we are then calling its method called stop. So the dot, period, or full stop, call it whatever you want, is how you access a method or property of an object. And so now when I press enter, that service is meant to have stopped. Okay, so just to confirm that that is the case, I'm just going to get the status here, and as you can see, Win32 time has stopped. Okay, now I'm going to start it again. Now I could just use the same command I used here and then replace stop with start. But instead, I'm going to say get service name Win32 time and then pipe it into start service dash path through. And as you can see now, it is started. Now, which method is better? To be honest, both work. However, using the start service commandlet is recommended. And the reason is very simple. Since get service is a get command, you would assume that you can only read information with it, that you're not actually making any changes. But in this case, as you can see, even though I'm using get service, I am then calling the stop method, actually making changes to my system, stopping the service. So it makes much more sense when you're actually making a change that affects the system to use the proper commandlet, like start service, so it's easier when you're reading through a script or whatever to know that this is going to change something in the actual system. Okay? Now you may be wondering why I put this pass through option here, and that's very simple. If I don't put that pass through there, okay, so let me show you what happens. You'll notice that I don't get any output, whereas if I put it here, you'll see I do. So what happens is that when I don't put that parameter there, the object that is returned from this entire command is the result of the start service commandlet. But when I say pass through, it means the object that is generated from this first part of the command, pass it through start service so I see its output instead. And as you can see, this time I get the result. Okay, so this is why the pass-through parameter is useful, okay, in certain cases. Now again, it may be a bit difficult at first, especially if you're new to PowerShell, to figure out when you'll need it. But by trial and error, you will get it, guys, so don't worry too much about it. As you can see, I've been using an awful lot of pipes today, so it's a good time for us to discuss pipelines. So a pipeline is basically two commands separated by this pipe symbol. The output of this side of the command is sent as input to this side of the command. So in this case, for example, this part of the command produces a service controller object, or Win32 time, which I'm then passing to start service, and so this way start service knows what it has to start. In our case, Win32 time. These are used to create what we call one-liners. So basically a bunch of different commands chained together using a pipe. And these can get really complicated, guys. Now one thing I want to show you is that they don't necessarily have to be on one line. So for example, look at this command here. Get service, and then I'm going to add a pipe and press enter. You will notice that PowerShell displays these two angle brackets or chevrons, call them whatever you want, where I can continue my command. So when you're typing a really long command, you don't necessarily have to type it on just one line. So for example, here I'm going to say get service where object can pause and continue equals true. Another pipe, enter. Select object property asterisk. So that's a pretty long command, but if you read it step by step, you can probably figure out what it's doing. So, get service, meaning give me the list of services. We saw this in the previous episode. Then, filter it. Show me only those objects that have a can pause and continue property, which is equal to true. Okay? And then for those list of objects, give me the properties of those objects. So when I press enter now, you'll see that I get a list of services, as you can see. So for example, here I have some sort of service, and if you can see here, it says can pause and continue true. Another service here, which is some sort of parallel service, since I'm using a VM, can pause and continue true. Another service here, which is svc host.exe, can pause and continue true. So as you can see, looking at the command initially may look daunting, because it's a really long command and you're like, what the hell is this meant to do? But if you look at it step by step, it's really easy to understand. Get the list of services, filter them where there's a property can pause and continue, which is equal to true, and then for the objects that have not been filtered out, select all of their properties. Okay, now we still call this a one-liner even though it's not on one line. Okay, we have simply separated the lines to make it easier to type maybe in a script or even in the command line itself. Now, one thing I want to clarify is that it's only if your commands are separated by pipes that they are a one-liner. So look at this example, guys. So I'm creating a variable here called service, which I'm going to set to, let's see, win32 time. Okay, and then I'm going to type semicolon, and then I'll say get service name, and I'll use the variable I just created, service. So basically I'm saying create a variable service with the value win32 time, and then get the service that I've specified. And as you can see, this works. However, this is not a one-liner, guys. This is two separate commands that happen to have been run in sequence. So basically I'm saying first do this and then do that. I could just as easily have written these on separate lines, because this is not providing any input to this. They are two separate things, and so we don't call that a one-liner. Okay? Now, returning to one-liners, one of the things we frequently do with them is we filter output. So if we go back to our long command here, you can see that we're getting all the services and then filtering them, so we only get services that contain this particular property. Now, typically, there's more than one way to filter your output. For example, get service name win32 time. Now this already contains the filter, because get service on its own would give me the list of all services. But I'm saying no, wait a second. Only those services with the name win32 time. And as you can see, we get the output. Now another way I could write the command is get service pipe where object name is equal to win32 time. So I'm using that same where object commandlet to filter my get service list. So I only get services with this name. As you can see, that produces the exact same output. These are interchangeable, but this is better than this, guys. The reason is, in this particular version of the command, Windows first gets the list of all the services that there are, sends them to the where object commandlet, and then it filters out that list. Whereas this version of the command immediately retrieves only those services which match the filter. So much less data is being processed here than is being processed here. Now in the case of the list of services on this machine, honestly, it doesn't really make a difference. But if you're getting a list of, for example, Active Directory users in a huge company, then this would be considerably slower than filtering straight away. So this technique is better, and it's called filtering left. So basically the idea is, when you're building a one-liner command, add your filters as quickly as possible, as early as possible to the left. so that you have less data to filter later on, as is with this case. Now, another thing about pipelines, of course, is that you need to know which commandlets accept which objects as their input. Okay, so for example, let's say I have the stop service commandlet, which obviously stops a service, guys. So I can say help, which we covered in the last episode, stop service, and I'm going to say full here to get the full help file. Now, if I scroll down in this help, there we go, we get to this section here, inputs. So you can see that the stop service commandlet accepts as input a service controller, such as the Win32 service controller, or a string. Okay, and it says here you can pipe a service object or a string that contains the name of a service to this commandlet. So it's telling you what it accepts. It's also telling you what it outputs. Okay, so either nothing or a service controller. This commandlet generates a service controller object that represents the service if you use the pass-through parameter. So as you can see, guys, by default, stop service generates nothing. Okay? However, if you use pass-through, it passes through the service controller. So let's look at this in action. Okay? So I'm gonna say, for example, get service name Win32 time and pipe it into stop service. As you can see, nothing is output because I didn't use the pass-through parameter. Okay? So none was the output. However, if I repeat the same command but I add pass-through, notice how now I actually get information from the service controller. Okay, because as it says in the documentation, if you use the pass-through parameter, you actually get the service controller you gave me in the first place. So basically, the input that the commandlet received is being passed through to the next item in the chain as output. And since in this pipeline here, there is nothing after it in the chain, it will go to the console, which is the default. And so I get the information. Now, whilst I'm here, I'm actually going to start my time service again. And there we go, we get it running. And again, we get the information since we used the pass-through parameter. Now, many times, in order to see what inputs and outputs a commandlet accepts, well, you have to use the help. Or honestly, you can use a Google search. However, there is a PowerShell module that can do this for us. So I'm going to open my browser here. And I'm going to go to PowerShellGallery.com. So this is a list of modules that the community has built for PowerShell. You can see the top downloaded ones here. Okay. In my case, I'm going to search for MR Toolkit. There we go. And this is a toolkit created by Mike F. Robbins, who wrote a book about PowerShell. And as you can see, it says miscellaneous PowerShell tools. Okay? And it requires PowerShell 3. So when any PowerShell extension needs to be installed, guys, you can simply, as you can see here, we can install it straight away into PowerShell. Now, rather than doing this, I'm actually gonna get some info about it first. So we can say something like find module dash name MR toolkit. And PowerShell will search the gallery and bring me information about this toolkit. And as you can see, here it is, MR Toolkit in the PowerShell gallery, miscellaneous PowerShell tools, version 1.3, blah, 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 blah. Okay, so now I can install it. Install module name MR Toolkit. And this will install the module. Okay, So as you can see, it says you are installing the modules from an untrusted repository. Remember, guys, that these modules are written by the community, not by Microsoft themselves. So if you're doing this at work, make sure that you analyze the code that you're receiving. In my case, I trust this, so I'm going to say yes to all. And as you can see, now it's installing the module, and voila, the module is installed. Now this module provides a number of features, but one of the useful ones is called get MR pipeline input. So what this does is it tells us what input object a commandlet accepts. So for example, here I'll say dash name start, let's do stop service. So basically what this does is it tells me that the stop service commandlet accepts either a service controller object as input on a pipeline or a string as input from a pipeline. Okay, so you can see here, guys, that this avoids me having to search through the help file. I can simply use this commandlet to get what inputs this guy accepts. Now I'm going to show you something here. Notice how this time I've passed a string to the stop service commandlet, and this makes sense because as you can see, the stop service commandlet actually accepts the name of a service as a string in addition to the service controller object itself. Okay, so if I actually look at now get service dash name win32 time, you can see that it is actually stopped, so this command worked. Okay, now of course, to get more information, I could have added pass through, but look what happens this time. Okay, you get the actual information because the object has been passed through. Now this is interesting because even though what I passed through was a string, stop service interpreted that string name as the object, the service controller object, and that's what I got information from. So obviously using the same technique, I can pass the string to start service, and as you can see now, the service is running. Now, I mentioned earlier about getting information in a certain format. Okay, so for example, I did get service dash name win32 time, and then I'm going to pipe it to select object property, and I'm going to say status display name can asterisk, so any property that starts with can. And as you can see, I get the output as a list because there are 5 items, and by default anything over 4 is displayed as a list. However, I can repeat that command and pass it to the format table commandlet, which as you can see overrides the default formatting to display it as a table. So it is up to you to determine what kind of format you want. Okay, so for example, if I repeat it again get service name win32 time, since by default I only get 4 properties, it's displayed as a table, but nothing stops me from passing it to format list this time. And as you can see, what's interesting here is that not only does format list display them as a list, obviously, but it also by default displays more properties. Okay, so the formatting commandlets aren't just from formatting, they also control what kind of information you get. Now there is one thing to note here, guys, and that is that when you pass an object through a formatter, the formatter changes the object type. Okay, so let's imagine I have this command here, get service name win32 time get member. You saw this earlier, it tells me what methods and properties it has. But now I'm going to add something in the middle of this command line, which is format list. But as you can see, when I do this, I get something totally different. What I'm getting here is the format list object types, methods, and properties, because now what getMember is receiving isn't the service, it's receiving the format list. Now, the sharper of you might have said, well, maybe there's some sort of pass-through. Well, we can try that. But as you can see, no. Format list, and in fact format table as well, guys, do not have this pass-through. Since format list doesn't actually receive an object type, it simply receives string that it's going to format. Okay, so be aware that basically your formatting is the last thing in your command line. Okay, which makes sense because normally that's what's going to be output, the last thing in your one-liner. Okay, so moving on here, one other thing I wanted to mention in today's episode was aliases. So aliases let you define a shortcut for a commandlet that you use frequently. So, for example, going back to this command here, rather than getMember, I can pipe all of this to gm. Hello. So apparently, gm is an alias for getMember. Okay, now how would I know this? Well, I can say get alias -name gm. And as you can see here, PowerShell is telling me that gm is an alias for getMember. So using getAlias and giving it a name, you can give it an alias and it tells you what it's an alias to. Now, obviously, if you're new to PowerShell, you're probably more interested in the other way around. Is there an alias for a command that I use frequently, like getMember? So in that case, you can say getAlias, but this time you use the property definition. And you give it the command that you want to find an alias for. And as you can see here, it's giving us the other way around. Okay, we gave it the commandlet and it's telling us, hey, there's the gm alias which points to getMember. Okay? And we can use this for other commandlets, for example, getService. And as you can see, there is this alias gsv, which is an alias for getService. You can obviously set your own aliases. For example, I can say set alias name, and then I can put my name here. So I'm going to say, for example, I don't know, srv_lst, okay? And I'm going to set its value to getService. Now, obviously, this doesn't really make much sense because there's already an alias for this, but, you know, work with me here. So now when I type srv_lst, you'll see it does the same as getService, guys. Now you can, of course, create an alias to a commandlet with parameters, but you can't do it directly. Okay, so for example, one thing I've been using a lot in this episode is the getService name win32 time pipe format list command line, right? Now I want to create a very simple alias that does all of this because I'm sick and tired of typing it every time. Well, unfortunately, I can't directly create an alias to this because it has options and the pipeline and whatever. But what I can do is encapsulate this in a function. So what I can do is I can go to this command and in front of it I'll type function and give it a name, time status, for example. And then I'll open a curly bracket and at the end I'll close the curly bracket. Okay? So now I can say set alias name, something simple like timestat, value, and then the name of my function, time status. So now whenever I run timestat, whoop, voila, I've run this entire command without having to put in the pipe and the service name and blah, 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 blah. So you can see how this gets really, really useful. The last thing I want to show you in today's episode is comparison operators. Now this will be a great segue into episode 3, where we're going to talk about flow control, but more on that later. Let's not get ahead of ourselves. So guys, look at this. PowerShell -eq PowerShell. And it sets true. So EQ is a comparison operator, and it tells me whether two things are equal. And in this case, PowerShell and PowerShell are the same. Now, notice how it's not case sensitive, guys. So the comparison operators on Windows are not case sensitive by default. However, I can add a C here to say case sensitive. And so now it says false because obviously here there's a capital P and S, but here there isn't. Okay? Now this can also be used for numbers. So for example, is 5 greater than or equal to 9? False, obviously, because it isn't. But is 9 greater than or equal to 5? True, it is. Okay? As you can see here, the comparison operators. Now, if you open up the documentation, PowerShell comparison operator, there we go. You can see that the official PowerShell documentation lists the comparison operators you have. And as you can see, equal to, not equal to, greater than, less than, blah, 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 blah. Okay, so there's quite a few which are simple comparison operators like these. There are these other ones, such as like and match, and obviously they're not variant. So what is that? Well, let's look at an example. So I can type something like PowerShell like shell, and it says true. So like is used to compare a string with another string containing wildcards, such as the asterisk, which is any number of characters, the dot, which is a single character, or the question mark, which is basically an optional character. Okay. Now each one of these also has a not variant, which obviously plays false in this case. If you want to use regular expression, you will instead use match. So in this case, I'm doing, for example, PowerShell dash match, and then I'm going to specify a very basic regular expression. Starts with any character followed by shell, and then the end of the string, for example. Now, if you're new to regular expressions, don't worry about it. It's a bit beyond the scope of this episode. Maybe in a later episode we'll cover it. And as you can see, this says true. Okay, so basically something that starts with anything followed by shell and then ending. And as you can see, that matches. Notice how it is case insensitive, guys, because this S of shell here is small. Okay? And there is not match as well. One thing I want to note, guys, is that you're seeing me create a number of strings here. By default, when we create strings in PowerShell, we always use a single quote. Okay? If we use a double quotation mark, that will be represented as variable interpolation. So for example, if I create a variable called my name and I set it to Keith, I can then say my name. As you can see, it says Keith. Now I can say my name is my name, and since that's in single quotes, it says my name is my name. But if I use double quotation marks, my name is my name, you can see that it says my name is Keith. Okay, so when we're using quotation marks like these, variables are interpreted. Okay, you can even see the coloring of PowerShell makes it obvious. Whereas the single quotes are literal strings. What you type is exactly what you're gonna get. Moving on to the last, moving on to the last thing for today. Contains. So let's generate a range of numbers here. Numbers equals 1.10. That's the range operator. Okay, if we look at numbers now, notice how it contains the numbers 1 to 10. Okay, we'll look more at this when we come to scripting. But I can do something like numbers dash contains 15. And that's false. There's no 15 in there. And there's also not contains. That says true. Okay. Another way of doing this is by using the in parameter, or the in option rather. For example, 8 in numbers. And it is true, because yes, there is an 8 here. Note, however, that this was introduced in PowerShell version 3. Now, the last of these operators that I want to show you is the replace operator, which is basically used as sort of part of what awk can do on Linux. It's used to replace parts of strings. So, for example, I can say here veggie burger, and then I can say replace veggie with beef. And as you can see, it gives me beef burger. Okay, notice again how it is case insensitive, guys. Okay, now there's another way to do this, which is veggie burger dot replace veggie beef. However, note how this time it doesn't work. And the reason is that whereas the replace option is case insensitive, the replace method, which is a method of the string object, is case sensitive. So in this case, it doesn't work because obviously it didn't find veggie. I would have to say replace veggie with beef, and then it actually works. So I think we've done more than enough for today's episode.
Well, that's the end of episode 2. We've covered objects, including their properties and methods, aliases, formatting, comparison operators, and a few other extra bonuses. In the next episode, we're going to be covering flow control, in other words, loops, which combined with comparison operators that we've seen today, give you the basics of sequence, selection, and iteration, allowing you to write scripts in PowerShell that do pretty much whatever you want. We'll also start talking about functions, which make the code in your scripts organized and reusable. If you're interested in Windows PowerShell, be sure to like this video and subscribe to this channel, and hit that bell notification icon so you'll be the first to know when the next episode comes out. You'll also find many other technology and gaming related videos on my channel, so go ahead and browse through. I'll catch you in the next episode, and until then, thanks for watching.